Let us discuss about the inverse DFT calculation using FFTs. We are aware that the equation for DFT and the equation for IDFT are as shown. So structurally, there is a lot of similarity between the DFT and IDFT equation. The DFT equation involves the input called as x of n. IDFT input has the input called as x of k. Total factor powers in the case of DFT are positive powers, whereas total factor powers for the IDFT is a negative power. Additionally, the answer finally is scaled by 1 by n. Therefore, the differences in the structure can be noted as follows. First, we have to interchange the inputs and outputs. What was the input will now become the output. Other words, x of k here is the input, whereas x of n will be the output. The total factor w of n is conjugated. We have w into the power of minus kn in place of w into the power of kn. And finally, we have to remember to multiply by 1 by n. Let us look at the inverse structure for DIT FFT. The inverse structure for decimation in time FFT that is used for IDFT calculation will resemble that of the DIF FFT structure used for DFT calculation. Hence, if we remember DIF FFT for DFT, we remember that the inputs are arranged in a sequential manner, whereas the outputs have an index which is in bit reverse fashion. Also, the size of the butterfly we have seen for the structure is a decreasing order. We start from the largest one and we progress to the smaller and smaller butterflies. Total factor multiplication happens after the butterfly. So structurally, there is a similarity between DIT FFT for IDFT with that of DIF FFT for DFT. Now coming to the inputs we remember for IDFT is x of k. Therefore, the inputs are x of 0, x of 1, x of 2 and so on till the last term x of 7 in sequence. Also, the total factor powers we remember should be negative in the case of IDFT. Therefore, the powers are W8 to the power of 0, W8 to the power of minus 1, W8 to the power of minus 2, W8 to the power of minus 3. These are the four total factors that are required to solve the problem for n is equal to 8. Also, we have to remember that the IDFT equation performs the multiplication with 1 by n. Therefore, at the end of the computation, all the outputs are respectively scaled by 1 by 8. And this gives us the result, which is small x of n, and the results are presented in a bit reversed manner. This is how the structure of DIT FFT for IDFT, or in other words, the inverse DIT FFT structure is presented. Let us consider a numerical on computation of IDFT of a sequence. The sequence is provided here. X of k is equal to, the values are 3.5, 0.5, minus 0.5, 0.5, minus 0.5, 0.5, minus 0.5 and 0.5. It's an 8-point sequence and you are asked to find IDFT using decimation in time FFT algorithm. Alternatively, the same question could have been asked as using radix 2 inverse DIT FFT compute the sequence x of n. So in the question you have to identify the method and use the appropriate structure. Now since the problem is for n is equal to 8, the number of twiddle factors that are required will be the first 4 twiddle factors. And the first 4 twiddle factors are W8 to the power of 0, which is equal to 1, W8 to the power of minus 1, because IDFT involves negative powers of twiddle factor. The value of this is 0.707 plus J 0.707. Next we have W8 to the power of minus 2, which will be plus J, and W8 to the power of minus 3, which is minus 0.707 plus J 0.707. So after listing out the first 4 values of twiddle factors, now let us go for the structure. As we have seen, the structure for IDFT will have the inputs, which is x of k. For these inputs x of k, the inputs are applied in a sequential fashion. So it is easy for us to tell that the inputs here are going to be applied sequentially, and the inputs are as follows. The first value of input is equal to 3.5. The second value is 0.5. Next comes minus 0.5. And so on. The data is applied in a sequential fashion. As we are familiar with the arrangement has butterflies which is larger to smaller. The output of the first stage will be the sum and the difference. Now for the respective inputs, let us calculate the sum and the difference. The sum here of the first pair of input, that is 3.5 and minus 0.5, the sum will be 3 and the difference will be equal to 4. Addition and subtraction operation yields this result. Similarly, proceeding for the rest of pairs of inputs, we can write the result. So here we calculate the sum. This is also the sum, and this is also the sum. Whereas the bottom, they are all the difference of the respective inputs. And the difference, when it's calculated, we get the answers as 0. Now, the output of the first stage has been computed. So this is the first stage output. The input for the second stage happens to be the appropriately scaled value. We have to observe that wherever we have twiddle factor, we have to multiply it by the appropriate value. In the top half, we observe there is no scaling in particular. Therefore, we can write the value 3, 1, minus 1 and 1 directly. Whereas in the bottom, we have to see what value is there and multiply with the respective twiddle factor. So the value W8 to the power of 0 is 1. So multiplication will give you the value 4. 0 is to be multiplied with the twiddle factor W8 to the power of -1, whose value we know is 0.707 plus J 0.707. In this example, the value is 0, hence multiplying will result in an answer which is 0. If the value was non-zero, you should have multiplied it with the appropriate weight and you should have got the value. So complex multiplications should be performed carefully. Now we see the last three terms are 0, so multiplication results in the value 0. Once again, to determine the output of the second stage, we have to add and subtract the respective terms. Therefore, adding the value 3 and 1, we get the sum as 4. The difference, which is calculated at this point, answer is going to be equal to the difference between the addition of 3 and, okay, just let me correct it. Let me rectify it, please. Okay, sorry for the mistake. Here, the sum is between 3 and -1. The inputs are 3 and -1. The sum is equal to 2 and the difference is equal to 4. The sum of 1 and 1 is 2. The difference equals 0. Again, the inputs are 4 and 0. Sum is 4. Difference is 4. 0 and 0. Sum is 0. Difference is 0. So this is the output of the second stage. Okay, it's a second stage output. Now, again, proceeding to the third stage, again we are going to perform the scaling with the twiddle factors and we're going to write the numbers. Now, the values, after you scale it, we shall write the numbers. The values are 2, 4, 0, because we are multiplying 0 with the twiddle factor value. This is 4, 0 because there is no scaling. W8 to the power 0 is 1, so results in the same value 4, and 0 multiplied by W8 to the power of -2. W8 to the power of -2, the value is plus J, but multiplication 0 gives you the answer 0. So we have calculated what is the input for the stage 3. Okay, third stage input has also been calculated. Now we have to determine the output. The output of this particular stage is calculated as, once again, the sum and difference between the respective inputs. We can observe that for the inputs 2 and 2, the sum will be 4 and the difference will be 0. Likewise, for the respective pairs of inputs, we have to calculate the sum and difference. So the sum here is 4, difference is 0. The sum here is 4, the difference is 4. The sum is 4, difference is also 4. The sum being 4 and difference is 4. Now that we have got the output of stage 3, to get the final answer, we have to scale these outputs by 1 by n. Therefore, multiplication by 1 by 8, each of these terms will give you the final answer. Therefore, we can write x of 0 after scaling, answer is 1 by 2. X of 4 is 0. This is 1 by 2. And correspondingly, we see that all the answers here are equal to 1 by 2. All the values are 1 by 2. It is important to note here that we are using the index here, which is arranged in the bit reversed index fashion. Therefore, as a conclusion, we can write the final result of the computation as follows. So in this problem, we have determined x of n from the given x of k by using the structure. Now while writing out the answers have to be written in the correct order. So first we have output x of 0. The answer was 1 by 2. Next comes x of 1, x of 2, x of 3. Then the output was 0, and correspondingly we fill in the remaining places in the correct order. Answer is bit reversed, so we arrange it in the appropriate fashion and we calculate the result. Thank you all.